Okay. Can you see the screen?
Yes,
Okay.
sir.
Now the next theorem is let phi1 and phi2 be two solutions of L of y is equal to 0 on an interval I. Okay, on an interval I, and x naught be any point in I. X not be any point in I, then the two solutions phi 1 and phi 2 are linearly independent if and only if the row skin at phi 1, row skin of phi 1 and phi 2 at point x naught, which is not equal to 0. Okay, त्याच्यातली special case आहे. Here we proved that what we have proved. Get it. If two solutions phi 1 and phi 2 of L of y are linearly independent on any interval I, if and only if row skin at point x, here the x is there, okay, is not equal to 0 for all x belongs to I. इंटरवलच्या प्रत्येक पॉइंट साठी ट्रू आहे. इथे काय प्रूव्ह करायचं आपल्याला? इफ ते स्टेटमेंट सेम स्टेटमेंट आहे, फक्त कोणत्याही एका पॉइंट साठी प्रूव्ह करायचं. ओके, एक्स नॉट बी एनी पॉइंट, पर्टिक्युलर त्या पॉइंट साठी आपल्याला प्रूव्ह करायचं. ओके, नाउ लुक एट द प्रूफ. Let phi 1 and phi 2 be two solutions of L of y is equal to 0 and x naught belongs to I. Okay, x naught belongs to I be any point. Suppose are linearly independent solution. Okay, we have to prove that. To prove that, row skin of phi 1 and phi 2 at x naught, that particular point x naught, is not equal to 0. Okay. Now we have by previous theorem. What we have? Not equal to 0. If phi 1 and phi 2 are linearly independent, then by previous theorem what we have? The row skin of phi 1 and phi 2 are phi 1 and phi 2 at x is not equal to 0. Okay, for all x belongs to I. Okay, any doubt? Any doubt up to here? Okay, now then,
No, sir.
obviously जर प्रत्येक पॉइंट साठी जर ट्रू असेल तर x नॉट साठी ऑब्वियसली ट्रू असणार. ओके, देन obviously we have row skin of phi 1 and phi 2 at point x naught is not equal to 0. Okay, any doubt? Now converse part.
No, sir. No, sir.
What is the converse? Suppose the row skin of phi 1 and phi 2 at point x naught is not equal to 0. Okay, now to prove that, phi 1 and phi 2 are linearly independent. Okay. C2 be any constant, be any constants. Consider C1 phi1 of x plus C2 phi2 of x is equal to 0 for all x belongs to I. ओके, आधी हे कन्सिडर करावं लागेल ना. मग ज्या C1 आणि C2 च्या व्हॅल्यूवर आपल्याला काय ठरवावं लागेल, ते फंक्शन्स इंडिपेंडेंट आहेत की डिपेंडेंट आहेत. ओके, now put for all x belongs to I, is this statement true? Then put x is equal to x naught. Okay, put x is equal to x naught in above equation. In above equation, then we get C1 phi1 of x naught plus C2 phi2 of x naught, which is equal to 0. Okay, any doubt? Wait a minute.
No, sir.
Now differentiate this with respect to x. Give it is equation number 1. Now differentiate with respect to x. We get C1 phi1 dash of x naught plus C2 phi2 dash of x naught is equal to 0. Give it as equation number 2. Okay, so equation 1 and 2 can be written as equation 1 and 2 can be written as in the matrix form. Okay, here phi1 of x naught and here phi2 of x naught and here phi1 dash of x naught and phi2 dash of x naught, and it is the C1 C2. This is the column vector, okay, which is equal to 0 and 0. Okay, now since the determinant, okay, we assume that the row skin of phi1 and phi2 is not at x naught is not equal to 0. It means that the determinant of this coefficient vector, okay, determinant of this coefficient matrix is nothing but what? Row skin, na? Okay, we have row skin of phi1 and phi2 at x naught is not equal to 0. We assumed that what it implies. Okay, phi1 of x naught, phi2 of x naught, phi1 dash of x naught, and phi2 dash of x naught. This the determinant of this is not equal to 0. But this is what? The coefficient matrix of this one. Okay. Hence, the determinant of coefficient matrix, this is the coefficient matrix, is not equal to 0. Therefore, the system, what is the system? The equation 1 and 2, this system, 1 and 2 system, 1 and equation 1 and equation 2. Okay, the system possesses a trivial solution. Possess a trivial solution. Okay, what is trivial solution? That is C1 is equal to 0 and C2 is equal to 0. Okay, and is there, okay, not or. It implies that phi1 and phi2 are linearly independent. Hence the proof. Any doubt up to here? Okay, any doubt up to here?
No, sir. No, sir.
वरचाच theorem आहे, फक्त x naught हा पॉइंट घेतले त्यात. Okay, now the next theorem is next theorem. Two solutions phi1 and phi2 okay, are linearly dependent if and only if their row skin phi 2 at point x is equal to 0 for all x belongs to I. ओके, तिकडे काय होतं, लिनियरली इंडिपेंडेंट होता आणि द स्किन नॉट इक्वल टू 0 होता. इथे लिनियरली डिपेंडेंट आणि काय, द स्किन इक्वल टू 0. ओके, नाउ लेट्स सी द प्रूफ. Let phi 1 and phi 2 be solutions of L of y is equal to 0. Now first part, suppose these phi 1 and phi 2 are linearly dependent solution. Okay, what it means, if phi 1 and phi 2 are linearly dependent solutions, then there exists a constant C1 and C2. Okay, there exists a constant C1 and C2, not both 0, not both simultaneously. Okay, simultaneously 0, such that C1 phi 1 of x plus C2 phi 2 of x is equal to 0. Okay, for all x belongs to I. Any doubt up to here?
No,
No,
sir.
sir.
Dependent solution, it means what? Either C1 or C2, both simultaneously not 0, such that C1 phi 1 plus C2 phi 2 is equal to 0 for all x belongs to I. Okay, now differentiate, give it as equation number 1. Okay, now differentiate with respect to x again. We get C1 phi 1 dash of x plus C2 phi 2 dash of x is equal to 0. Okay, give it as an equation number 2. Okay, now equation 1 and 2 we write, can be written as, again in the matrix form, can be written as, okay, phi 1 of x, phi 2 of x, phi 1 dash of x, phi 2 dash of x, and this is C1 C2 is equal to 0. 0 is the column vector. Okay, since look at here now, the statement is important. Since the system here, the C1 and C2 both not 0, it means so that the system has non-trivial solution. Okay, either C1 or C2, one of them is not 0. It means that this system of equations possesses a non-trivial solution. Okay, understood up to here? The system
Yes, sir.
possesses a non-trivial solution. Non-trivial solution, that is the rank of coefficient matrix. The rank of that coefficient matrix is less than 2. Okay, the rank of coefficient matrix 2 असला असता तर काय झाला असता, ट्रिवियल सोल्युशन आला असता. आपल्याकडे नॉन ट्रिवियल सोल्युशन आहे. इट मीन्स दॅट रँक ऑफ दॅट कोएफिशिएंट मॅट्रिक्स, दिस मॅट्रिक्स, ओके, इज लेस दॅन 2. जर हा 2 क्रॉस 2 चा मॅट्रिक्स आहे आणि याची रँक येते लेस दॅन 2, इट इम्प्लाइज दॅट द डिटर्मिनंट ऑफ phi 1 of x and phi 2 of x phi1 dash of x and phi2 dash of x. Okay, is equal to what? Very good. Is equal to
0.
0. But this is what? Row skin of phi1 and phi2. Okay, it implies that what is the value of this one is row skin of phi1 and phi2 at point x is equal to 0 for all x belongs to I. Hence the first part is proved. Okay, any doubt? Now the
No,
converse
sir.
part. Okay, now the converse part. Suppose W skin of phi1 and phi2 is of x is equal to 0 for all x belongs to I. Now to prove that phi1 and phi2 are linearly dependent functions. Okay. Now again consider C1 phi1 of x plus C2 phi2 of x is equal to 0 for all x belongs to I. Okay, this is the equation number third. Okay, where C1 and C2 are constant and C2 are constants. Now differentiate 3 with respect to x. With respect to x, we get, okay, we get C1 phi1 dash of x plus C2 phi2 dash of x is equal to 0. Give it as equation number 4. Now again, equation 3 and 4 can be written as in the matrix form, can be written as phi1 of x, this is phi2 of x, this is phi1 dash of x, and this is phi2 dash of x, and this is the column vector c1 and c2, which is equal to 0 and 0. Okay, any doubt up to here? But we assumed
No,
that
sir.
what we assumed converse part, in the converse part, we suppose that the row skin of phi1 and phi2 are 0. Okay, row skin of phi1 and phi2 at point x is equal to 0. Okay, we have, but we have what we have row skin of phi1 and phi2 at point x, which is equal to determinant of phi1 of x, phi2 of x, phi1 dash of x, phi2 dash of x is equal to 0 for all x. Okay, belongs to I. We have this one. It means that what it means, this above system of equations possess a non-trivial solution. ओके, जर 0 झाला तर काय होणार, रँक कमी होणार या मॅट्रिक्सची. या मॅट्रिक्सची रँक कमी झाली तर काय होणार, नॉन ट्रिव्हियल सोल्युशन होणार. ओके, hence the coefficient matrix is of rank less than 2. Okay, this shows that the above equation, the above system of equation, system of equation, the above system of equation possess a non-trivial solution. Non-trivial solution, that is either C1 is not equal to 0 or C2 is not equal to 0, which means that phi 1 and phi 2 are linearly dependent. Okay, hence the proof. Any doubt up to here? जो आपण वरच्या
No, sir.
इंडिपेंडेंटचाच तो थेरम प्रूव्ह केलाय त्याचाच इथे कॉन्व्हर्स पार्ट आहे. ओके, हे तसं प्रूव्ह करायची काहीच गरज नाही आपल्याला. Two solutions phi 1 and phi 2 are the equation of L of y are linearly dependent if and only if rho is 0. तिकडे काय होतं, if and only if म्हणल्यानंतर काय होणार, if P implies an implied Q, it means that Q is implies an implied negation of काय ना, look at here, त्याला लक्ष द्या म्हणजे कळेल. P implies an implied Q. What it means? Negation of Q implies an implied negation of P. Okay, मग याचा contrapositive statement काय येणार? If rho is not equal to 0, if and only if they are linearly independent. Okay, तेच त्याला आपण आधी प्रूव्ह केलेलं आहे. Okay, understood up to here? Any doubt up to here? कळते ना शिकवलेलं
No,
काय
sir.
चालू आहे? ओके, तुम्ही ऐकत
हो
असाल तर
सर.
कळेल आणि रेग्युलर असाल तर कळेल. ओके, नाउ द नेक्स्ट थेरम. आधी सांगितले एक्झाम्पल्स तुम्ही आपल्या एमएससी आणि थेरम्सच भरपूर आहे. ओके, द नेक्स्ट थेरम, लुक एट हियर. लेट phi 1 and phi 2 be any two solutions, any two linearly independent, okay, any two linearly independent solutions of L of y is equal to 0 on an interval I. Okay, then every solution phi of L of y is equal to 0 can be written as uniquely as phi is equal to C1 phi 1 plus C2 phi 2, where C1 and C2 are the constant. समजतोय का स्टेटमेंटचा अर्थ? बघा नीट लक्ष द्या. आपण ह्याच्या आधी खूप वेळा यूज केलंय, फक्त आपण हे इथं प्रूव्ह करतोय की phi 1 and phi 2 are the solutions of linearly independent solution. Okay, not dependent. आपण काय म्हणत होतो, if phi 1 and phi 2 are the solutions of L of y, then the linear combination is also solution. But here phi 1 and phi 2 be any two linearly independent solution. Okay, तिथे any solution असेल तर आपण linear combination always solution म्हणून सांगतोय. जर phi 1 and phi 2 be any linearly independent solution of L of y, then we can write that phi is equal to C1 phi 1 and C2 phi 2. This phi is also solution of L of y. Okay, and this representation is unique. Okay, unique, it means what? It takes C1 and C2 constant value. It's kind of unique. Okay, it's even the meaning of theorem. Okay, now let's see the proof. समझते का स्टेटमेंट का अर्थ? Okay, any doubt in the theorem? रिप्लाय द्या काहीतरी, आवाज मला कोणाचाच येत नाही. ब्रेक होतोय का आवाज? वेट अ मिनिट. एकच मिनिट थांबा. नेट नेट जात असेल कदाचित. येतोय का व्यवस्थित? ओके. Any
Yes,
doubt
sir.
in the statement? Okay. If
No, sir.
phi1 and phi2 be any two solutions, linearly independent solution of L of y, then their linear combination is also the solution, and this solution is unique. Okay, the unique solution of L of y. Unique means what? That C1 and C2. There exists a C1 and C2, both are the constant, are unique. इकडे दुसरे C1 आणि C2 येणार ती एकच असतील कुठली तरी. एकच म्हणजे ह्याची व्हॅल्यू एक आणि ह्याची व्हॅल्यू एक. ते कॉन्स्टंट युनिक असतील. ओके. Then this phi is also unique. Okay, so this is the theorem. Now let us see the proof. Okay, now let x naught be any point in I, any point in interval I, and phi1 and phi2, okay, are linearly independent solutions of L of y is equal to 0. Okay, on interval I. Okay, the phi1 and phi2 are the linearly independent solution of L of y is equal to 0 on an interval I. Okay, now let phi be any solution of L of y is equal to 0, and also consider that, and phi of x naught is equal to alpha, and phi dash of x naught is equal to beta. Okay, where since alpha and beta are real numbers. Okay, real numbers. Now, as phi1 and phi2 are linearly independent on I, then we know that, okay, we know that rho skin of phi1 and phi2 at point x is not equal to 0 by previous theorem. For all x belongs to I, na? Interval for I, interval in x belongs to I, for all x belongs to I. Okay, why? Because phi1 and phi2 are the linearly independent on I. Okay, what it means? The system, which system? This one. Phi1 of x and phi2 of x, phi1 dash of x and phi2 dash of x, with column vector c1 and c2, which is equal to 0, 0. Okay, now consider this system. Consider the system of equation. This one. Okay, so this one is alpha and this one is beta. Okay, consider the system of equation. This one, phi1, phi2, phi1 dash, phi2 dash, with alpha, beta are the any two constant. But we know that rho skin of phi1 and phi2 at point x is not equal to 0 for all x belongs to I. Therefore, the above system of equation, the above system of equation has unique solution. Okay, युनिक सोल्युशन का म्हटलंय? कारण की ते अल्फा आणि बीटा आहे. ओके, जर 0 असेल तर काय म्हटलं असतो आपण? trivial solution. Okay, now here the above system of equation has unique solution. Why? Because this determinant is not equal to zero. Hence, this matrix invertible matrix. इन्व्हर्टिबल मॅट्रिक्स नंतर काय होणार C1 आणि C2 चे कॉन्स्टंट रँक काय होणार त्याची 2 होणार. इफ रँक इज इक्वल टू 2 then C1 and C2 has a unique solution. Okay, then therefore the above system of equation has unique solution C1 and C2. Okay, any doubt up to here?
No,
For
sir.
the choice of C1 and C2, for the for that choice for that choice for okay sorry for that choice we have taken the function consider the function psi of x is equal to c1 phi1 of x plus c2 phi2 of x. C1 C2 काय ना जे तुमचे ते युनिक सोल्युशन येतील ह्या C1 आणि C2 त्या चॉईस साठी आपण काय फंक्शन कन्सिडर केलं psi of x. Then psi of x is equal to c1 phi1 plus c2 phi2 of x. Okay, now let psi of x naught is equal to c1 phi1 of x naught plus c2 phi2 of x naught. Okay, which implies that phi of x naught is equal to alpha. Similarly, psi dash of x naught is equal to beta. And also, if psi is the solution of, and also psi is the solution of what? L of y. And also, and also, we have L of psi is equal to 0. Why? Because psi is the solution. Okay, this shows that phi and psi are solutions of initial value problem. L of y is equal to 0 and phi of x naught is equal to alpha and phi dash of x naught is equal to beta. Okay, but by uniqueness theorem, by uniqueness theorem, which we've seen in the previous lecture, uniqueness theorem for initial value problem, we must have phi equal to psi. That is, phi is equal to c1 phi1 plus c2 phi2. Okay, any doubt up here? Okay,
No, sir.
युनिकनेस प्रूव्ह करताना काय करायचं आहे त्याच्यासारखाच दुसरा फंक्शन घ्यायचा आणि ते दुसरी दोन्ही वेगळे नसून एकच आहे सांगितलं होतं आपण. Okay, so this is the theorem. If phi1 and phi2 be the any two solutions, linearly independent solution of L of y on an interval I, then every solution phi is of the form C1 phi1 plus C2 phi2, and this solution is unique solution. Okay, any doubt up to here?
No, sir.
आता इथपर्यंत जे अभ्यास हे झालेला आहे सिलेबस तो सेकंड ऑर्डर होमोजेनियस लिनियर इक्वेशन होता. Okay, now we are going to study दिस अप टू हिअर काही डाऊट असतील तर ते विचारू शकता. ओके, जायचं पुढे. जायचं का? Now, the next part
Yes,
is
sir.
the second order non-homogeneous linear differential equation. Okay, याचं फक्त फॉर्म बघूयात कसं असणार बघूया आणि त्याचा प्रूफ आपण नेक्स्ट लेक्चर बघूया. ओके, look at the second order non-homogeneous linear differential equation. The differential equation of the form L of y is equal to y double dash plus a1y dash plus a2y is equal to not zero here. Here the b of x, because we study non-homogeneous linear differential equation. Okay, b of x is called second order non-homogeneous linear differential equation. Okay, any doubt? Where
No, sir.
b of x is continuous function, where b of x is continuous function on an interval I. ओके, हा बी ऑफ एक्स जो असेल, जो राईट साईडला आहे, तो काय असणार? कंटिन्युअस फंक्शन ऑन एन इंटरवल आय. ओके, तुम्ही बीएससी ला असताना जर सेकंड ऑर्डर होमोजिनियस असेल तर फक्त कॉम्प्लिमेंटरी फंक्शन करतो. ओके, आता तुम्हाला इथे काय काढावं लागेल? कॉम्प्लिमेंटरी फंक्शन प्लस पर्टिक्युलर इंटिग्रल. Then we
Particular
can write
integral.
complete solution is y is equal to f of x, cf plus pf. ओके, आता आपल्याला पी एक जर काढायचं असेल तर आपल्याला ती मेथड, आता प्रत्येक फॉर्मचे वेगवेगळे मेथड्स आहेत ना, पर्टिक्युलर इंटिग्रल काढायचे. ओके, ना ते आपल्या सिलेबसला पर्टिक्युलर इंटिग्रल काढण्यासाठी एक फॉर्म्युला डिफाईन केलेला आहे. ओके, ते आपल्याला त्या फॉर्म्युल्यानुसारच काढावं लागेल. ओके, any doubt up to here? The second order non-homogeneous linear differential equation. Okay, हा पार्ट समजलाय?
No, sir.
ओके, एक थेरम घेऊयात, स्टेटमेंट बघूयात आणि त्याचं प्रूफ आपण नेक्स्ट लेक्चरला घेऊयात. ओके, नाउ लेट्स सी थेरम. Let us see the theorem. Let b of x or b be a function on an interval I. Every solution psi of L of y is equal to, here what? Not zero, here b of x. Okay, on I can be written as okay, psi is equal to c1 phi 1 plus c2 phi 2. This is the complementary function. And what is the particular integral? Plus psi p. Okay, this psi p is nothing but particular integral, where this psi p is a particular integral of particular solution. particular solution. And phi 1 and phi 2 are linear, are two linear independent solution of L of y equal to what? 0. Okay, characteristic equation वगैरह घेऊन. Okay, so these phi 1 and phi 2 are the linearly independent solution of L of y is equal to 0. C1 and C2 are constants, a particular solution, and also a particular solution psi p is given by, it's given by, now look at here, particular integral काढायचा formula. Okay, what is psi p is equal to integration x naught to x into bracket, whole bracket, phi 1 of t into phi 2 of x minus phi 1 of x into phi 2 of t upon rho skin of phi 1 phi 2 of t, the whole bracket complete, with b of t, जो काही तुमचा b असेल तो इथे असणार function into dt. Okay, where the psi p is given by integration x naught to x and this one whole is. Okay, so this is the theorem for the level. Okay, any doubt up to here?
No, sir.
Okay, wait a minute. काही डाऊट असतील तर तुम्ही विचारू शकता बरं का.